All right, so I need to solve this equation on number 45, page 610. I have a double angle here, and I have a single angle there. So I can't really isolate either of those by factoring or anything clever like that. So I need to kind of write this double angle as a single angle. So I'm going to use the identity, cosine of 2 theta. Now you have 3 choices, but since I have a cosine here, I'm going to pick the option that has just cosines. I believe that is it. So let's rewrite it. Where I see this, I'm going to replace it with this. So 2 cosine squared theta minus 1 plus cosine theta equals 2. You get everything on the same side. Subtract 2 minus 3. Hopefully this is factorable. 2 times negative 3 is negative 6. Factors negative 6 that add up to 1. That would be positive 3 and negative 2. So I'm going to make the outside product the negative 2. I'm going to make the inside product the positive 3. Okay. Set each of these equal to 0. So the cosine of theta is equal to negative 3 halves. And the cosine of theta is equal to positive 1. This is negative 1.5. So unit circle time. So the cosine is equal to 1. The x-coordinate is 1 here. The cosine is equal to negative 1.5, like right about there. Obviously, that's not a good ratio. No solution comes from it. So my answer is 0 plus 2 pi k. If you wanted the infinite, over here they asked for just the finite solutions on the unit circle. So theta equals 0. We don't want 2 pi. 2 pi would be the next one, but that's outside this interval, so you want that one just out. This is the first one.